This is a typical dynamic programming question, and it asks us to determine the maximum profit we can achieve by robbing houses, with the constraint that we cannot rob adjacent houses. In other words, if we choose to rob one house, we must skip the immediate neighboring houses. For instance, if we rob the second house, we cannot rob the third house and must consider robbing the fourth house. To provide a clear explanation, I will illustrate the concept by drawing. To approach this problem, we can formulate an equation to find the maximum profit we can achieve. Let's consider a particular house. Let's call this house X. The specific values of the houses are irrelevant at this point, so just ignore them. I don't write them. Suppose we are currently at house X. This house is going to be X minus 1, X minus 2, X plus 1. And these X values represent the indexes of these houses in the house array. The maximum profit we can achieve on this day is determined by maximum of two scenarios. Let's write an equation. dpx is equal to maximum of two things. So what are those things? First, it is the maximum profit obtained from the previous house. And the second is the maximum profit obtained from the two houses before, which is x minus 2, plus the profit gained from robbing the current house. By comparing these two options, we can select the best choice. If we opt to maximize the profit of two houses before, we can rob the current house. However, if we already robbed the previous house, we cannot rob the current one because we cannot rob the adjacent houses. So, this equation allows us to calculate the maximum profit iteratively as we progress through the array of houses. Ultimately, we will return the maximum profit achieved on the last day since it incorporates the highest profit attainable using the all houses. So we will return this one. This DP is gonna return the maximum profit can be obtained until the X day. That's why we wrote it. So let's get into coding part. Now let's examine how we can implement the solution in code. Check the length of the houses array. If the length is equal to 0, it means there is no house, just return 0. If n is equal to 1, it means there is just one house, return the profit we can achieve by robbing the first house. If not, we will create our array to store the maximum profits that can be obtained until a specific house. Now iterate through the array using a for loop. Leave it empty here, just write the equation we discussed earlier. Since we need to go back two houses, ensure that the for loop starts from the index 2 to avoid runtime errors. So let's write it. For the base cases of house 0 and house 1, we have to manually assign the maximum profits that can be achieved because they are initially 0. And at the end, return the maximum profit achieved using all the houses. This will be the value stored in the last index of the maximum profit array. Regarding time and space complexity, the algorithm iterates through the array only once, resulting in a time complexity of O(n), where n is the number of houses. Let's write it down. And the space complexity is also O(n), since we used an additional array to store our maximum profit values for each house. And let's execute our code. So let's check the performance on Leetcode. As you see, the runtime is perfect, but the memory, the space complexity is a bit poor. So let's look at how we could improve our space complexity. Let's consider a scenario where we at the fifth house. In this case, we only require information from the previous house and the two houses before it. The information preceding these houses is irrelevant to us. Therefore, we can avoid storing unnecessary data in an array and instead use two variables. This improvement allows us to achieve a constant space complexity as opposed to the previous space complexity of O(n). So let's rewrite the code with this approach. Now we will create two variables called current and previous. We can take the length of the houses array again. Now we can use these variables in the equation we discussed earlier. Additionally, we need to update the data for the two houses before. So we assign the value of the previous day's data to the variable representing the 2 days before, like this. But there is something we need to pay attention. This is not actually representing the one house before data because we updated it here. So we have to take the unupdated one at first and then write it here. So at the end, we will return the maximum of current and previous day's data because the current represents the robbing the last house and previous represents the robbing the house before the last house. So let's check the performance on Leetcode. As you see, the space complexity is also improved. I hope it has been helpful to you. Thank you for watching.